So I left my paper kind of scooted down like this so you could still see the Punnett square. If you have been following along, then you would realize that we did a few examples in the upper left-hand part of the Punnett square in the level 3 problems, and then the upper right-hand uh, corner of the Punnett square we did the level 4 problems in which we had exponential equations in which the two sides can't be written as a power of the same number, so you have to go to logs. Level 5 problems where you have logs on both sides. You might have to combine some logs, but you have logs on both sides and then same base, so you just equate the arguments. So there's very little work to do there. And then our level 6 problems are where we're going to start seeing, okay, we're going to get a logarithmic equation, but we don't have logs on both sides, only log on one side. And when we have that, we want to convert to exponents. So that's where we're at right now. So level 6. Here we have a logarithmic equation. We can just convert right to exponents. 2 to the third is equal to x. Hopefully this has become second nature. 8 equals x. We want to check to make sure we're allowed to plug in 8. And sure enough, we are allowed to plug in a positive number. And then exercise B, we have logarithmic equation. We have the log of something equals something, so we're just going to rewrite that using exponents. So we have 1/2 to the negative 4 is equal to the argument x minus 1. So what do we do with this? Well, 1/2 to the negative 4 is the same as 2 over 1 to the positive 4, right? 2 to the fourth. So 1/2 to the negative 4, you could write that as, well, I mean, you could do a couple steps in there, but I guess 1 to the negative 4 over 2 to the negative 4, 1 to anything is 1, 2 to the negative 4 downstairs is 2 to the fourth upstairs. So no matter how you slice it, you still get 2 to the negative 4, which is 16. So 16 is equal to x minus 1. Adding 1 to both sides, we get x equals 17. And take a quick glance over here. Can you put 17 in there? 17 minus 1 is 16. Log of 1/2, log base 1/2 of 16, does that equal negative 4? 1/2 to the negative 4 equals 16. Check. Yeah. So if you have very little time, just make sure at least you can replace x with the number that you're saying that x is equal to. Okay, and that you can take the log of that. All right. And then exercise C, we have log of something equals something. The base is e, the right side is 3, is equal to the argument e cubed is equal to x. You can just leave it just like that. E cubed is a positive number. We take the log of a positive number and we're good to go. All right, let me see if we can finish these last 5 problems here in this video. See if we can. Now, level 7 problems are there's maybe 1 or 2 more steps than the other level problems, but now that you have all of those other ones under your belt, maybe pause the video and see if you can tackle these ones on your own. If we have a logarithmic equation, we typically, almost always, I can't think of an example right now when we wouldn't want to do this, but we want to combine the logs. And so using the properties above, we have the sum of the logs, which is the log of the product, is equal to a number. Now we have the lower right corner of the Punnett square, so we're going to rewrite this. The base raised to the right side is equal to 5x. So 5x equals 100, and if we divide both sides by 5, 100 divided by 5 is equal to 20. So x is equal to 20. Okay, x is 20. Log of 100 is equal to 2, because 10 squared is 100. So check. You're allowed to plug 20 back in. And then over here, same thing. We have logs, multiple logs on the left side. We're going to combine all the logs into one using the properties. The property of logs, meaning the difference of 2 logs is the log of their quotient. And we have the log of x over 5 equals the log of 5. Now we're in the lower left-hand corner of the Punnett square, where we have logs that have the same base. So if the logs have the same base, we equate the arguments. And if we multiply both sides by 5, we get x is equal to 25. Give a quick check. You're allowed to take the log of 25, and so you're allowed to plug in 25. I forgot to put a check mark to the last one. And there you go. So if you think about it, log of 25 minus log of 5. Well, that's the log of 25 over 5, and 25 over 5 is 5. So log of 5 equals log of 5. So it fits. It works. So we found the only real number that solves that equation.